A rectangular piece of paper is 12 centimeters high and 6 centimeters wide. The lower right-hand corner is folded over so as to reach the leftmost edge of the paper. Find the minimum length of the resulting crease. Let's assume AN is X, BN is Y, and MC is W in this diagram. Therefore, AM is 6 minus X, CP is 12 minus W, and BQ is 12 minus Y. Since AN and AC are the same, AC is also X and CB is Y. Don't forget this is the folded part of the paper, which is the same as this front. If L is the length of the crease, L2 would be X2 plus Y2. And X2 is the same as W to the power of 2 plus 6 minus X to the power of 2. That means W is square root of 12X minus 36. X must be greater or equal than 3 and smaller or equal than 6. Because if X is less than 3, this corner doesn't reach edge PM, and X obviously cannot be more than 6. The area of the paper is 12 times 6, which is 72. This can be written as the addition of the area of trapezoid PQBC, which is 12 minus Y, plus 12 minus W, divided by 2 times 6, plus area of triangle AMC, which is 6 minus X times W divided by 2, plus area of triangle ABC times 2. With a little bit algebraic manipulation, we find y times x minus 3 equals half of xw. And we know w is square root of 12x minus 36. This means y is xw square root of 12x minus 3 divided by 2 times x minus 3. Therefore, L can be written as square root of x2 plus the square of x root 12 x minus 3 divided by 2 times x minus 3, which is the same as square root of x2 plus 3x2 divided by x minus 3. X must be greater than 3 because x cannot be 3 anymore, and is smaller or equal than 6. We take the derivative of L with respect to x. The derivative is derivative of this function divided by 2 times L. We let derivative equals to 0. X cannot be 0, therefore 2 plus 3x minus 18 over x minus 3 to the power of 2 must be 0. We bring 2 to the right side and cross multiply and find the value of x. X is 9 over 2. We use first derivative test to show this corresponds to the minimum of L. X is between 3 and 6. At 9 over 2, derivative is 0. For x less than 9 over 2, derivative is negative. For x more than 9 over 2, derivative is positive. Therefore, function is decreasing when x is between 3 and 9 over 2, and it is increasing when x is between 9 over 2 and 6. Therefore, 9 over 2 minimizes L. If x is 9 over 2, y would be 9 over square root of 2, and L would be 9 root 3 over 2. Therefore, 9 root 3 over 2 is the length of the shortest crease. Thank you.